Hello there, brothers and sisters. I am your host, your brother, your professor, Mr. O'Neil Barnaby, founder and director of the Black Math Academy, here with another video showing you what intelligent black society is all about. Today, I thought I'd do something a bit different and switch gears from my usual video tutorials and do something a bit more interesting. So today, I'm going to visually prove the Pythagorean Theorem. Typically, when you do a proof, you use a two-column process. First, you have a given statement, and then you conclude information from that given statement, and then you have to justify each conclusion with theorems, with definitions, with axioms, with postulates, until you ultimately prove what you're trying to prove. I'm going to skip all that and just use some visuals and a little bit of algebra as well. So, without further ado, I want the proof. You can't handle the proof. Actually, you can. Let me show you how easy it is. All right, so the Pythagorean Theorem, everybody should remember that very famous formula back in geometry class. It states that a squared plus b squared equals c squared. All right, so you have this formula here. Just to be a bit more clear, the Pythagorean theorem is used only for right triangles. It does not work for any kind of triangle that exists. So anytime you use the Pythagorean theorem, you have to use it for a right triangle. And what it states is that as long as you know two sides of that right triangle, you can figure out the third side of that right triangle. You just plug in the values that you know and just solve for what you don't know. All right? So this visual that I have here, I use a big square and I put a smaller square inside of it for all three of these images. And what I basically did was calculate the area of all three parts. So in the first image here, we have the area of the big square. The blue shaded region is the area of the entire square, the big one. The second one here, the blue shaded regions are the four triangles that are in the corners of the big square. So that area there. And this third image here, the blue shaded region is the smaller square inside the bigger square. So what this basically states is that the area of the big square, or the entire thing, minus the area of the four triangles inside, equals the area of the smaller square inside. I'm going to show you that how that can translate into the Pythagorean theorem itself. So for the big square, we have the side down here, which is this A and this B value here. So the distance from here to here is A, and from here to here is B. So that side length would be A plus B total. And because it's a square, all the sides are the same length. So each side is actually A plus B in total. So the area of the square, remember the formula for the area of a square, which is base times height. So A plus B is the base, A plus B is the height. So A plus B times A plus B would be the area of the entire square, the big square. So that's its representation here, the area. For this part here, we have these four triangles, and we want the area of that. Well, remember the formula for the area of a triangle. It's base times height divided by 2, or 1/2 times the base times the height, no matter which one you use, because it's all a product anyway. So let's say you looked at this triangle here, this one on the side. So A would be the base, B would be the height. So A times B, and then divide by 2. So A times B divided by 2. Now that's the area of just one triangle. We actually have 4 of those triangles. And as you can see, all 4 of those triangles are the same. A and B is the base and height, A and B is the base and height, A and B is the base and height, A and B is the base and height. So since we have 4 of them, and this is the area of just one, multiplied by 4, and that'll give you the area of all 4 triangles. So this value times 4 would be the area of all 4 triangles. And that would result into this image here where we have the square, the smaller square inside the bigger square. Now, again, the area of a square is base times height. As you can see, all the side lengths are the value c. So c times c would be the area of the square inside. So c times c. So minus and equals. So we have a plus b times a plus b minus 4 times a times b divided by 2 is equal to c times c. Now we can just perform a little bit of algebra to see if we truly get the Pythagorean theorem in the end. So a plus b times a plus b, that's an example of FOIL because you have a binomial or a two-termed expression multiplied by another binomial. So you would perform FOIL to accomplish that. So I'm going to do it a little bit faster. So a plus b times a plus b is a squared plus 2ab plus b squared. And then we're going to subtract 4 times ab divided by 2. We can simplify that part actually because since we're multiplying these two things, 4 is on top and 2 is on the bottom. So we can actually divide that. 4 divided by 2, exactly what it says. So 4 divided by 2 is just 2. So this becomes 2ab. All right, and then equals c times c. C times c is c squared. Anytime you multiply the two exact same values, whether they're numbers or variables or expressions, in fact, it's the same as squaring it. So c times c actually equals c squared. So a squared plus 2ab plus b squared minus 2ab equals c squared. So now we're going to do some more simplifying. If you notice, you have a plus 2ab rather right here, and we have a minus 2ab right here. So because this entire equation here is just a bunch of adding and subtracting, PEMDAS tells you to add first and then subtract. But because they're opposite operations of each other, it doesn't matter which one you actually do. You can actually pick which one you want to do and just go from left to right instead. So we can combine these two right now. So positive 2ab minus 2ab is 0. It's like adding and subtracting the same number from each other. 5 minus 5, 10 minus 10. It'd be the same thing. So this actually disappears. So that goes away. That goes away. What's left is this and this. So a squared plus b squared equals c squared. And voila. By this visual proof, I've just shown you that when you take the area of the big square minus the area of the 4 triangles, you get the area of the smaller square inside. And that happens to be the Pythagorean theorem itself. A squared plus b squared equals c squared. And there you have it, folks. The Black Math Academy demonstrates once again why we are your premier source for mathematics tutoring. As you can see, we don't just show you the information that you need to know in school, but we also show you why you need to know it and where it comes from. We demonstrate that we are clear, we are concise, and we are articulate, which makes us without peer. Don't forget to like, share, comment, subscribe, and follow all of our social media pages, Facebook, Instagram, and YouTube. And always remember that if hard work is the key to success, most people would rather pick the lock. Math is where it's at.